Okay, class, now that we know how to manipulate roots, we can actually solve equations using, by taking the nth root of both sides. So first off, if you are solving and you take like a third root or a fifth root when n is odd, there's only one possible solution, one real root, and it's whatever sign the actual number is. So if it was negative, it'll stay negative. If it's positive, it'll stay positive. If you think about square roots for this. If n is even, think square roots. You take the square root of both sides and the number you're taking the square root of is positive, you get two real roots. You get a plus or a minus that could happen. If it's even and a equals 0, then a just has one real root and it's 0. When you take any type of root of 0, you still get 0. And finally, if n is even, so again think of square roots, and a is less than 0 or negative, a has 0 real roots. You cannot take the nth root of a negative number. I should say take the even nth root. I'm going to actually write that. Of a negative number, because you could take an odd. You can take an odd root of a negative number. So let's look at how to solve these. We get 6x to the fourth equals 3750. First thing we do, we divide by 6. We get x to the fourth is equal to 625. Now at this stage, remember, I like to use fractions. How could we cancel out a fourth power? We can fourth root it. Or you can say, so we can do that, or you can raise it to the 1/4 power. You can do this as well. These are, remember, equivalent. You can do either of those. And what I would do, and since it's an even root, we're going to have plus or minus for our final answer. Just like if it was a square root. Now, you can use your calculators and see if it's a really nice number, so you don't have to do all the breakdown work. And sure enough, raising 625 to the 1/4 power is 5. So the answer is just plus or minus 5. So you can use your calculator to get that value. Now that doesn't always work out though. For example, this problem next. Right away we have to break apart this root. So I'm going to third root it. We're allowed to third root it because it's an odd number, an odd index. So I'm left with x plus 1 is equal to the third root of negative 18. Real quick, this is 9 and 2, 3, 3 and 2. Nothing breaks out of there, so it's just kind of the way it is. And then finally we move the number over. We get negative 1. You can pull the negative out though, actually, and write it like that. Okay, because negative 1 times negative 1 times negative 1, there are 3 of them. You can pull the negative out. You can always pull the negative out when you have an odd root. So there's that. That's the final answer. Alright, this is actually a review problem from quadratics because this is a square. So we first subtract 7 and we get x plus 5 is equal to 16. I'm sorry, x plus 5 quantity squared is equal to 16. Now we're going to take the square root of both sides, and since it's even, we're going to have two possible answers, and the square root of 16 is 4. So now at this stage, you move the 5 over by subtraction, and please, if they are both numbers, add them together and subtract them together. So negative 5 plus 4 is negative 1, or the other answer is negative 5 minus 4 is negative 9. So x can equal both of those numbers. Okay. Finally, we're going to move the 2 over by addition. So we get 3 quantity x plus 5 to the 5th equals 192. Next thing we do is we divide by 3. Excuse me, we have x plus 5 to the 5th is equal to 64. Now we're going to take the 5th root of both sides. It's an odd, so we're only going to get one solution. And I get x plus 5 on this side, and I get equal to the 5th root of 64. Now we have to break this down. Hopefully you guys know that this is 8 and 8, and these are both 2 cubed. So That's 2 to the 6th. So I get x plus 5 equals the 5th root of 2 to the 6th. You can move this over. Negative 5 plus the 5th root of 2 to the 6th. Double check to see if you can simplify that, and sure enough, you can pull a 2 out. So the final answer is negative 5 plus, we can use 5 of them to pull a 2 out, and we're left with the 5th root of just 2 to the 1st power. Okay, so that's just using your power or your breakdown properties. Okay, let's keep going. We got a couple more of solving. So the next page, we move the 12 over by subtraction, and we get 576 equal to 8 parentheses x minus 4 squared. Next, we're going to divide by 8, and we get 72. Since we're going to now root this by an even, we're going to have a plus or minus the square root of 72 over here, and we get an x minus 4 over here. Now you can break this down now or at the end. If you like to get it all equal to x first, you can do that. We move the 4 over, it becomes plus. Now at this stage, simplify the root 72. 8 times 9. We got 2 to the 3rd, and we get 3 squared. And again, you used to do this for, we have the square root of 3 squared times 2 to the 3rd. Since the index is 2, because it's a square root, we can pull a 3 out and a 2 out. So our final answer is 4 plus or minus, when we pull a 3 and a 2, you multiply those together, you get 6, and then there's 1 2 left under the root. So it's 4 plus or minus this 6 root 2. Okay, last one of solving. Move this over by adding 4, which is negative 33. Divide by 3, negative 11. And then we do the 8th root. So I'm going to 8th root this and 8th root that. Now be careful. What power, or what is this, even or odd? This is even, and this is negative. So we can't go on from here. We can't say plus or minus 8th root of negative 11. We will say, well, I'm going to write it out anyway. But since we have that, you can't take an even root of a negative number. Now, when it was a square root, we would use i's, but we're not going to do that here. We're going to just say no real root. Okay. Now, I would like you, if it was a square root, to use i's still, but if it's any other number, like 4, 6, 8, do not use i's. Okay, so that is solving, okay? It's like before, but now you have more tools at your disposal. You can take roots to solve. Alright, simplifying. Now we're just doing what we've been doing for a while now. This is the 5th root of 3 over the 5th root of, I'm going to break that down, 2 cubed. Remember, to rationalize, you need more of the 2's on the bottom. We need 2 more 2's to make it a full 5. So I'm going to multiply by the 5th root of 2 squared. So the top becomes 3 times 2 squared, which we'll figure out in a second, and the bottom just becomes 2, because there's enough. And since there's not enough to pull anything out on the top, the final answer is 4 times 3 is 12 over 2. 5th root of 12 over 2. Whenever I see things with different indices, I like to write them as fractions. Personally, that's just how I like to do these. Because the base is the same, which means you can subtract these if you want. But in order to subtract them, we need a common denominator. So if I multiply this by 7 over 7, I get 35/63. If I multiply this by 9 over 9, I get 27/63. So if I subtract 35 minus 27, I get 8 out of 63. And I can then rewrite that as the 63rd root of x to the 8th. So that's my final answer. Okay, this is a straightforward break down the numbers type problem. 4096 is 64 times 64, which we just did this actually. 64 is 2 to the 6th power. So I have the 8th root of 2 to the 12th. Then you look at this and say I'm going to use 8 of them to pull a 2 out. So I have 2, the 8th root of 2 to the 4th. And now here I would like you to simplify this fraction. I have 4 over 8, right? This is the same thing as 2 to the 4/8, which you can simplify to 2 to the 1/2. So my final answer is 2 square root of 2. Okay? Alright, we have to break down for number 10 the number. So this, I had an 81 and a 96. 81 is 3 to the 4th, so that's one thing broken down. 96 is 3 and 32. And then we know 32 is 2 to the 5th. And we have another 3 here. So what happens is this is rewritten as we have 3 to the 5th and 2 to the 5th under here. And we have an x to the 4th, a y to the 9th, and a z squared. Now remember, for these you can just divide the power by the index number. So 5/3 you can pull a full 3 out. 5/3 you can pull a full 2 out. 4/3 you can pull an x out. 9/3 you can pull a y cubed out, and you can't touch the z. So I have the 3rd root of, there are still 2 3's and 2 2's under there. There's one x left under there, and there are still 2 z's because nothing came out. So to simplify it completely, we have 6xy cubed on the outside, and then the 3rd root of 9 times 4 is 36xz squared. Okay, 2 more. One of my favorites. I keep saying that. This one's a little trickier because we might have to rationalize. I like to turn all these into fractional or lowest bases, and then get the same index for all of them. So we have 2/3, 3 to the 2/3, times 5 to the 1/4, times 2 to the 1/4, over 3 to the 3/4 times 2 to the 3/4. Okay, first of all, 3 and 4, I'm going to get these all to 12ths before I do anything, just to make my life easier. So 8/12. This is 3/12. This one's also 3/12. This is multiplied by 3, 9/12, and 9/12. Okay, so the 5 doesn't go anywhere, but we have to look at the 3's and the 2's. Notice how there's more on the bottom than top for both of them. So 8/12 over 9/12 gives you a net 3 to the 1/12 on the bottom. And then for the 2's, if you look at the fractions, 3 minus 9 is -6, which means 6 on the bottom. And I'm going to leave it in 12ths because we have to keep the same index for these problems. The top is still 5 to the 3/12. Okay, so here's what you do next. These numbers are on the bottom of a fraction, and you have to remember these are roots. We cannot have roots, so we have to rationalize the denominator. Now normally we did this like this. Like I would need something like that because I have 1 3, I need 11 more. But you can do this with fractions as well. I know I usually don't do that. And then for 2, I need 2 to the 6/12. So on top I need the same thing. And all the top does is we have those 3 things on top. So I get the bottom now has 3 to the 1/12 and 3 to the 11/12, which is 3. 2 to the 6/12, 2 to the 6/12 is just a whole 2. The top is all of this. So it's 5 to the 3/12, 3 to the 11/12, and 2 to the 6/12. Now I can rewrite them all under my 12th root. I have 5 cubed. Since it's going to be a big number because 3 to the 11th is pretty big, we're going to just leave them as powers and then all over 6. So that one's a little trickier because you had to rationalize with the fractional exponents. Okay, Last one, we have an m as an index. Clearly 12 does not raise to any m power, so that's stuck under there. We can divide this by m and get an a to the fourth on the outside. Can't divide that by m. C to the m over m is c to the first. D to the 5m plus 1, this first part divides by m, so we can get d to the fifth out, but we still have d to the first inside. So then we're left with the mth root of 12, b cubed, and then d to the first, because that's that one that couldn't divide. And that's the answer. So those are more simplifying. And that is, so today that was solving by taking the nth root, and then we did a couple more simplifying ones.